And we want to start off with junk.
Okay.
Now, I will always put it in scare quotes like that.
Yes.
Because it's just not true. That's what people call it, but it really, really isn't.
But we're told that up to 90-something% of the entire DNA code, the genetic code, is junk. It's meaningless. It's evolutionary leftovers from the past.
Right. That's what they would say. The reason they say that is because it doesn't code for protein. So they think, well, if it doesn't code for a protein, then is it really important? And it falls into different categories. They actually have different types of junk. So just like, I guess like you have different types of garbage. You have non-coding RNAs, repetitive sequences, and pseudogenes. That's just a couple of the different categories.
Okay.
And as we said, like if this is a pie chart of our entire human genome, our entire DNA, that tiny little green sliver there is the protein coding genes.
Wow.
Okay, the genes, that's the 2%.
Okay.
Right, so it's kind of, I think, easier to visualize that way. The other 98%, that's considered junk.
Now, from a biblical perspective, how could a creator, God, have designed something that's 98% junk?
Well, he wouldn't, right? I mean, when we start out from a design perspective and a creation perspective, we look for design. We look for function in there. And like you said earlier, what the evolutionists, when they look at it, they say it's a genetic fossil. Just like we dig up fossils in the ground, this is a genetic fossil. It's leftovers from our evolutionary past. So when we had tails and fins and all of those things, but we don't need them anymore.
Yes.
Susumu Ono was actually a geneticist back in the 70s that first kind of coined that term. He said, the earth is strewn with fossil remains of extinct species. Is it a wonder too that our genome is a wonder that our genome too is filled with the remains of extinct genes, right? So things we just don't use anymore. Like we used them when our ancestors were a fish, but we don't use them anymore. Our ancestors were a monkey, but we don't use that anymore. And since the release of the human genome, really in the early 2000s, and discovering that we only had 20,000 genes, which was really shocking, there's been a lot of interest actually in studying the junk. Okay, so we've come a long way since the 70s in looking at that. And probably the biggest group that has studied this is called ENCODE, which stands for Encyclopedia of DNA Elements. So this involves scientists from all over the world. It's a great collaborative project really looking at the DNA, because there's a lot of DNA, okay? So it takes a lot of computers and a lot of people to really analyze this. And they've published dozens of papers now in scientific journals that help us understand what that DNA is really doing.
Okay.
So phase 1 was completed in 2007. Now, they just looked at 1%, okay, 1% of the junk. And what they found was that it's actually transcribed into RNA. And when I showed that first original picture, normally you go DNA, RNA, proteins, okay? This goes DNA, RNA, and stops, and it doesn't go to proteins.
Okay.
So what's it doing? Well, it's what we're trying to figure out. It's doing something as RNA. And we've got it, we're just doing something even as DNA. It has function in and of itself. It doesn't have to go on and become a protein, so to speak. It's doing something. And so people were shocked, literally shocked by this. They said we are now seeing the majority of the rest of the genome as active to some extent.
Really?
Again, it totally goes against evolutionary ideas, right? This can't be true. Francis Collins, the head of the NHGRI at that point, said there's a lot more going on than we thought. And the current scientific director said, the take-home message is, oh my gosh, this is really complicated. Which is probably my favorite comment. Well, of course it's really complicated.
But isn't that what we find in almost everything? It's not surprising. No. All sciences, whether you're talking about astronomy or geology or biology or genetics, whatever, the takeaway is that there's a lot more going on than we ever thought possible.
It's a lot more.
It's very complex.
It is.
But complexity doesn't stop there. It's also very designed.
It is. It is. And so the more that we, if you think about it, that 2% has to be highly regulated, right? You've got to have a lot of the quote-unquote junk to regulate that 2% in all the cells in the body under all conditions. I mean, that you got to have a major regulatory mechanism in place. And that's not going to come about by random chance. So in 2012, they studied the remaining 99%, and they found that 80% they termed as being functional because it had specific biochemical activity. Things were binding to it. It was producing something that then went on to become active. and it's something about it is saying, hey, this is an active piece of DNA. It's not just junk.
So first they were looking for just pieces of DNA that encoded for proteins or something like that. And they noticed that only a few percentage.
Right.
And then they said, well, let's look at another percent of what the junk is.
Right.
And then they said, well, it's doing something. And then they're looking at the other 99% of the junk.
Yeah.
And they're saying that over 80%.
Over 80%.
And that's just the figure now.
That's the figure
Wait
now.
a few years.
Yeah. That's my guess.
Actually is doing something significant.
And I love what one of the ENCODE researchers he said almost every nucleotide, every base is associated with a function. Wow. Well, of course it is. I mean, we wouldn't expect God to create us with 98% junk. And even the lead coordinator said it's likely that 80% will go to 100%.
Okay.
I mean, he believes, no, it's not to say that we don't have mutations or things that aren't functional anymore because of the fall, but this is clearly designed. This is not disorder. This is not what you would expect from evolution.
This is exactly contrary to what you would expect if evolutionary biology is true.
Right, exactly. And that's why I think they were so shocked by it. We've even found, and I say most of the things they're finding with it, it's regulatory, but they're even finding variations in junk DNA have been linked to disease. Huh. And so this is an area they never looked at before, right? So things like schizophrenia, diabetes, heart disease, celiac disease, all of these, they're finding mutations in the junk DNA. Now that they know it's functional, they're like, oh, let's look there and see if maybe that's the problem.
Wow.
So it's the regulation that's off in a lot of these cases, not the genes themselves, but the regulation of the genes that's the problem.
Now, if I could be so bold as to make a statement, it seems that by assuming that you had all of this junk DNA, these scientists, evolutionary, atheistic scientists, were holding back progress.
Absolutely. I say that all the time. I think that has inhibited science way more than the creation science or biblical science perspective, knowing that this was designed by God. I think how much further could we be if we only had believed that in the first place? Yes. So what is some of this junk doing, And so some of it has a function just as RNA, which we're not going to get into, but it does. Some of it is actually involved in the packaging of the DNA. You've got 6 feet of DNA in every cell, okay?
Okay.
It's a lot of DNA. So you've got to package it up. And so some of that sequence is involved in packaging. That's the repetitive DNA. Some of it, they say it's non-functional copies of functional genes. And we're finding out they're really not non-functional. They're really doing something. And so some of it's turning genes off. Some of it's fine-tuning things. Some of it's only important during embryonic formation. When a baby's growing in the womb. It's important then, but not important later.
Okay.
Right? Which makes sense that you would have a lot of that there. They've even found mouse embryos, they've knocked out some of the junk DNA. They don't develop, they die. Really? It's not junk.
It's not junk at all. It's actually
definitely
doing
not
something important.
Right.
Now, to put a fun perspective on this, and I don't know if anyone has ever replicated these numbers or not, but Dr. Werner Gitt once said that in this packaging, this beautiful packaging of DNA, if you were to package it all together like it is, a pinhead full of DNA might reach, if stretched out, from the Earth to the moon, 500 times.
Yeah, that's very plausible because it's just there's so much there. We have trillions of cells, and each one of them has a nucleus with DNA in it.
And so it's literally like having book after book after book after book of information in us in a microscopic form that makes us individuals.
Right, right. So, I mean, even the fact that when we meet a foreign agent, like a microbe that we haven't seen before, our body has the ability to generate immunity to that. That's amazing, right? So how do you do that? And part of that comes from the junk DNA. But even so, a lot of evolutionists still don't believe it. P.Z. Myers, who's a well-known evolutionary biologist, said, the bottom line, though, is the genome is mostly dead. Transcriptionally, the junk is still junk. And another one said, the majority will always remain evolutionary baggage. And that's what amazes me, right? I mean, it's staring them in the face. This is observable evidence, and yet they say, nope, it's still junk. But I like what these scientists said. They say, we'll come to think of junk DNA as a critical component of truly expert cellular control regime.